Anxiety grew that radioactive carbon dioxide produced in the atmosphere during nuclear bomb tests would dissolve in the oceans and contaminate sea life, upon which Japan depends for much of its food. This anxiety prompted research on the fate of carbon dioxide in the atmosphere. In 1957, Roger Ravelli and Hans Suess of the Scripps Institute of Oceanography in San Diego conducted some key experiments that revealed some good news and some bad news about nuclear testing and carbon dioxide. The good news was that only a thin upper layer of seawater rapidly exchanges materials with the atmosphere, and thus contamination of sea life from nuclear testing is highly localized. The bad news was that only a thin upper layer of seawater rapidly exchanges materials with the atmosphere, and thus oceans remove only a small portion of the carbon dioxide being released into the atmosphere. Most of this gas remains airborne. This implied that carbon dioxide released during the burning of fossil fuels would not dissolve in the oceans, and so atmospheric concentrations of this greenhouse gas would rise rapidly as fossil fuel burning increased. Dave Keeling, a colleague of Ravelli and Suess at Scripps Institute, began in 1957 to monitor atmospheric concentrations of carbon dioxide at sites that were distant from industrial sources. The first site was at the South Pole, where concentrations rose steadily. The second was an observatory atop Mauna Loa volcano, 11,000 feet in elevation, on the Big Island of Hawaii. The carbon dioxide concentration first rose rapidly at Mauna Loa, but then declined just as rapidly. Keeling initially thought his carbon dioxide analyzer was broken because the values at South Pole never went up and down. He soon realized he was just observing the annual cycles of biological activity from the vegetation that surrounds Mauna Loa. Plants photosynthesize relatively rapidly during the summer and remove carbon dioxide from the atmosphere, and so atmospheric carbon dioxide concentrations fall. During the winter, plant and animal respiration exceeds photosynthesis, releasing carbon dioxide to the atmosphere, and so atmospheric carbon dioxide concentrations rise. Funding to support the South Pole Station ran out after 2 years, but the station at Mauna Loa has provided a nearly continuous record for over a half-century. During this period, the annual atmospheric carbon dioxide concentration has increased by over 20%. This trend of rising carbon dioxide has now been observed at monitoring stations worldwide. Public awareness of global warming increased when a man named Michael Mann and colleagues incorporated a variety of temperature measurements into the 1999 numerical chart affectionately known as the hockey stick. The shaft of the hockey stick corresponds to the nearly constant temperatures for the past millennium, and the upturned blade corresponds to the abruptly rising temperatures of the last century. The trends in temperature match those in average and annual atmospheric carbon dioxide concentration. This chart has generated much controversy, even provoking several congressional investigations. Finally, in 2006, the National Academy of Sciences of the United States, an organization that advises Congress on scientific matters, deemed that the hockey stick chart is generally correct. The average temperature of the planet is warmer than it has ever been in the last 500 and perhaps 1,000 years.